All right, good morning, and welcome to lesson 4.4, scatter plots and lines of fit. A scatter plot is a graph in which two sets of data are plotted as ordered pairs on the coordinate plane. If y increases as x increases, we say that is a positive correlation. If y decreases as x increases, we say that is a negative correlation. And if x and y are not related at all, then there is no correlation. So there are three total possibilities here. Again, a scatter plot is a graph in which two sets of data are plotted as ordered pairs on the coordinate plane. We're going to talk about positive correlation. So the data would be increasing from left to right, kind of like a positive slope situation. Then we talk about negative correlation, and you'll see the line or the data, the little points that are scattered, will fall from left to right. And if there's no correlation at all, it'll be a big mishmash of nothing. Okay, so there are certain things that definitely have a relation and other things that do not. So we're going to look this morning and investigate together. As soon as we make this, there we go. All right, here we go. So this first example here we have is Carmen's earnings, how much he made, and how much he saved. The graph at the right shows the amount of money that Carmen earned each week and the amount that she deposited in her savings account. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. Okay, so we can see that the data is increasing from left to right. Even though it doesn't form a perfectly straight line, what would you all say what type of correlation this is? Positive. Exactly. This shows positive correlation. The more Carmen earns, the more money she puts in the bank. Does that make sense? Yes? Okay, so let's look at these exercises in your notes. Determine whether each graph shows a positive correlation, negative correlation, or no correlation. If there is a positive or negative correlation, describe what's happening. Okay, average weekly work hours in the U.S. Okay, so these are the years since 1995, and these are the number of hours that people worked. Now, let me just go ahead and tell you, if you were collecting data on a science experiment and you were in the lab, you would say, you know, I could probably take these two numbers here and throw them out. Why? Why might I throw those two pieces of data out or ignore them? What kind of a trend do you see with the rest of this data? What kind of a trend do you see? A negative correlation. So how would you explain that? As the time goes on, people work what? Less and less hours. And that's how you're going to describe it. So we're going to let you guys go ahead and do numbers 2, 3, and 4 right now. We're going to let you guys go ahead and do 2, 3, and 4. As I grab my notes. God bless you. All right, let's look at number 2 together. What kind of correlation would you say number 2 shows? Somebody be bold. Negative correlation. And who can explain it? It's negative correlation. Okay, right here in the front, you explain it.
As the time passes, the person begins to get slower.
As time increases, speed decreases. Good job. Are you with me? And then let's just look at 3 and 4 real quickly. Number 3 shows what type of correlation, guys? And number 4 shows what type of correlation? Good. All right. All right, moving on. Scatter plots and lines of fit. Probably the best definition that I could give you for a line of fit is it's the best line that you could draw that would fit through the set of data. A line of fit. So let's go ahead and look at this next section here. This example shows a table and the number of students that shared a computer in Easton High School for certain school years from 1996 to 2008. So in 1996, there weren't many computers in the schools. There were 22 students per computer. In 1998, is that 18? In 2014, in 2002, 10. In 2004, about 6. In 2006, about 5. And in 2008, about 4. Now, everybody, of course, you guys all bring your own computers to school, and we don't have to worry about having computers in the back of the classroom. So what we want to do is we want to construct a scatter plot and determine the relationship that exists. Positive, negative, or no correlation. So remember, when they give you the data in this format, the top is going to be your X variable, the bottom is your Y. And that's why years is on the X-axis and students is on the Y-axis. And you plot them as ordered pairs. So let me just give you a little help when you see one like this in your homework tonight. So you can start at the year 1996 and go to 2008. They went 1996, that's 97, 98, 99, and so on. Now they went, and students, they went, each line was 4, increments of 4. They graphed the points, and then this black solid line is called the line of fit. Are you with me? Yes? So we graphed the data, we drew our line of fit, and now it says, write the slope-intercept form of an equation for the line of fit that passes through 1999-16 and 2007-4. So I'm going to stop here and make a comment, because many years ago in my older curriculum, they'd say, write an equation in slope-intercept form for the line of fit. But if we didn't all pick the same points, the line could vary a little bit. So when you have a question like this, we will be specific and tell you which points to pick. Okay? So the first thing you have to do is you find the slope, then you plug it into the point slope form, and then you can write it in slope-intercept form. All right, so let's go ahead and do one together. So the first thing we're going to do is refer to the table for exercise 1-3. So here's our table. I'm trying to see what this is supposed to say. This is supposed to say admission prices. Sorry, I don't think it did it copy on yours?
No.
Okay, admission prices in dollars. Okay, and we're talking about the movies. So, since 1999, admissions prices, $5.08, $5.39, $5.66, $5.81, $6.03. These are the years, okay? The years. So the price back in 1999 was how much, guys, for a movie ticket? $5.08. And then we saw it starting to go up. So you would actually go ahead and plot that. So you may plot that like right about here. And then it went to $5.39, which might be here. And then it went to $5.66, which is probably here. And then $5.81. And then $6.03. So if you had to look at that data, what type of correlation would you say existed? Positive correlation. If you had to draw a line of fit, it might look like that. Now remember, when you draw your line of fit, your line is not going to hit every single data point, okay? And again, we want to use rulers for this. Write the slope-intercept form of an equation for the line of fit. So let's give you the 2 points to use. Let's use these. Let's use So I'll be specific for the homework tonight too. Let's use 0, 5.08, and 3, 5.81. And let me do that with you. Are you ready to draw the line of, to write the equation? Okay, so we want to write an equation in y equals mx plus b form for the point 0, 5.08, and 3, 5.81. I label my points x1, y1, x2, y2, and I find my slope. Is that right? 0.73 over 3? I don't have a calculator up here. Can somebody tell me what that is? I'm sorry, what did you say, Justin? 0, 5.8, 3, 5.81. I think it's positive.
It's positive.
Yeah, positive.
Okay.
So it's about 0.24. Okay? It's about 0.24. Okay. So if we want to, we can go ahead now. Let's just show you. Our life's a little bit easy here. Why? Because we could actually see what the y-intercept is. What's the y-intercept, guys? Where's that graph crossing the y-axis? At 5.08. So now we have the two ingredients. What are the two ingredients you need? We have m, our slope, and we have the y-intercept, which is 5.08. So our equation would be y equals 0.24x plus 5.08. Are you with me?
Yeah.
Okay. Well, that concludes our lesson for today. Stay tuned for tomorrow as we finish up the chapter.